Good morning. Hope everyone's enjoying Coalesce in beautiful sunny San Diego so far. I know I don't have a lot of complaints, but I also live here, so there's that. So today we're going to talk about how we at ClickUp scale a monolithic repo and how we pull the levers to make it super computationally slim and efficient and make sure we're saving on our Snowflake credit. We're a Snowflake shop, so we're always being mindful of that. So just a quick agenda today. We'll go through intros, myself, ClickUp as a company, a little bit of our data team. So if you hear any hecklers, my colleagues are all here in full force here in the front. It'll probably be them. And then we'll go through just our dbt job setup. We'll go through how we have GitHub set up, and then some dbt functionality that we employ, and then just some metadata, and I'll try to reserve some time in the end for a Q&A if there's any. So I chose the title to be replicate David and Goliath slightly. I'm not going to reference it a lot. This is going to be one of the only references, but I figured, we took our valiant ClickUp data team and we throw dbt at a monolithic repo in hopes that we kill the beast. So that's kind of where the theme was, and I'll leave it at that. I do have a disclaimer here that with dbt 1.6, they have released a lot of features. These, like the strategies we're going to go over, are things that we were doing prior to these features coming out through dbt. So we are looking to transfer to more native functionality, but these are things we were doing to kind of make our pipeline a little bit more efficient. So just want to call that out. So anything that you see in blue, I'll attempt to be like, this is functionality that's coming out in dbt now. So go through introductions. Myself, I'm Michael Revelo. I lead our data platform team at ClickUp. We're about 20 people strong. We have a core centralized data team, but we also have embedded analysts, so we are a hybrid data team. To an extent, some of our data engineers are also embedded, so we just kind of have a little bit of that hybrid approach, and we do what works for us. So we'll go through a little bit of our architecture high level. So we have a pretty modern data stack. We definitely look to get tools when we don't have a lot of resources, the build versus buy. Can we use a tool that is going to be cheaper for us to use and make sense in our pipeline and in our tech stack? So the way that we set up dbt is pretty standard across the board. We have a base layer for standardization. This is where we clean column names, where we clean data types. We conform everything so that somebody's not calling created at and someone else is calling it created date. We have conformity across the board. Then we have an intermediate layer. This is where we materialize it as ephemeral. So if you're familiar in dbt, it's essentially a CTE that doesn't live in your warehouse. What we do here is all of our removal of deleted records, malformed records, anything we want to take out that we don't want to persist through to the final layer. And that final layer is where 90% of the downstream models will be built from. This is going to be our cleanest model of our source that everyone can reference. It's slightly duplicative of base and final because those base columns are going to be passed through to final. But you can also treat them as two separate models, especially when you're trying to do something like a historic look back. You're going to need those deleted records. So there are going to be those cases where you're going to want to point at base, but for the 90% of the time, you'll point at XF, and that's kind of the way we set it up that way. So we have that flexibility to look at either model depending on the use case. After that, one other thing that we keep strict to is in final, we keep it source dependent. So if you have like a Salesforce account table that you want to join to a Salesforce user table, you can do this in final. But as soon as you want to join another source like Salesforce account table to like NetSuite data, that's no longer in final, and that goes against some of the standards that we put. You're now traversing into the common space or to the Mart space. And for us, Marts are kind of embedded. So we have our core Mart, but then we also have Mart like product, Mart finance, Mart marketing. And so we keep our models like siloed into those. And for us, common is anything that can be reused across any of those marts. So something like our user identity model, maybe finance wants to use that, or marketing wants to use that for segmentation. So it's something that could be reused across the marts. So we'll keep going. We'll get a little bit into our dbt job setup. So we employed SlimCI like very early on when SlimCI was deferral by job. SlimCI nowadays is deferral by environment. So we had it set up deferral by job. And so you can see here, we have 3 environments. We have our dev environment. Let me take a step back. So our dbt approach is hybrid. We do all of our local development in core, and we use cloud for orchestration. So the way we set that up is all of our development is local. We push to a development database. We have a schema per colleague or analyst, analytics engineer who's in the repo. And then we have our beta environment. early on, we kind of went against the grain, and we had a shared beta environment for all of our team members. We didn't do a schema per PR. We kind of just maintained it all, and it was a little bit easier for us to maintain, but as we'll get into, as we scaled, we started running into collisions with that approach, so we had to quickly change it, but it worked early on. And so what we did was we had a PR job. When you submit a PR, it triggers a CI job. That defers to our merge job, so when that PR is approved and it merges, the merge job will go through production, but we triggered our PR job to defer to merge because we have one daily build in the morning, but we can have multiple merges throughout the day. So we want to take the most recent merge to give us the most recent snapshot of our production data, and so we want those PRs to always reference the merge. That way it's updated. And so the merge also kind of referenced itself because they wanted the next point prior to that where it kind of left off. And then the build just referenced itself, mostly because the merge is going to be like a partial state, and we want the full state from the prior day. So there might have been some stuff that happened intraday that it's missing and that we might be rerunning slightly, but we want to make sure we're encompassing the full picture of those deferrals. And so you can see here what we are running as part of Slim CI. It's both deferrals and also the way you set it up. I think there's a pointer here. I don't know. But here on the bottom, you see that we run dbt build state modified +1. Generally, people, I think, do modified plus and let everything downstream run. We chose to just do one downstream just for ease, because we felt like if there was a failure one downstream, then there's a problem. But anything past that, it's not likely to happen. So we're really going to take that risk just to not overrun models. Because we knew that in the merge job we have modified plus, we're going to run the full downstream because we want production, to be up to date as much as possible. So technically, if there were an error super downstream, we could quickly add another PR and fix it, and we'd be back to that state. So let me step back. So we have this yellow blob here, and this is what I mentioned. We all shared one beta database. So we did cloning. So every time the build would finish, we had a macro that would take our production environment and clone it to our beta environment, because we were all doing our local dev against that beta environment. So we wanted to have production data that everyone can leverage and do their local work. And we had a macro to do that. There's some callouts I want to say. So as I mentioned, we're a Snowflake shop. You can only clone permanent tables. We chose to do transient tables as part of our setup because we wanted to save on storage. You don't have failsafe, so it's cheaper to store a transient table than a permanent table. But you can't clone those. So the way we got around that is there's this weird thing where you can clone by schema. So whatever's in the schema, regardless of if it's permanent, transient, or a view, you can clone that entire schema and everything will kind of ride along. And so we were just cloning by schema. It got to the point, though, where that was still taking a long time, 10 to 15 minutes. We had it as a run operation at the last step of our build. It started bottlenecking, the refresh rate of our data, because now we're waiting on this build that we don't really need. We just need it as our internal team, our data analytics team. So we actually kicked it out into its own job. But dbt didn't have a concept of using a job to trigger another job. So we had to do something silly where we just set it on a cron job where we're like, hey, the build tends to finish at this time. Let's clone, maybe 10 minutes after. Nothing super intelligent. It was like, this will get us by. If for whatever reason the build failed, we had to remember to manually clone it. Very hacky, but it was working for us. So eventually, like I mentioned, there was that bottleneck. So there's a company, select.dev, that does a lot of blogs about sales, Snowflake optimization and cost optimization. And so they had a blog that said, use Python and threading to do the cloning, because you could do table by table, model by model, and you can do cloning at that point, in a minute. So we had to build it outside of dbt. And we also had another macro that would do clone to local. So every one of our team members could run this macro to clone production environment to their local schema, m Revelo _, et cetera, everyone into their local schema. But this was still taking, 12 to 15 minutes. It was taking a really long time for our analysts and our team members to get up to speed in their, day-to-day. So dbt clone, which is why I put it in blue. This is a new feature coming out. But there's still a little bit there that it's not super easy. Because especially for people who are on core, you need to set up a job that takes your production manifest, pulls it down, into your repo, so all your local colleagues can pull it from main and have it on their local machine. Because you need something to defer to. You need that state, you need that deferral to defer to, but you also need to know how to add the defer and state flags. And for us, we needed a lot of hands-on keyboard, so we brought analysts into our DBT repo because we needed the help. And traditionally, they don't necessarily always know GitHub, they don't always know CLI. So there's like a little bit of a training curve that's needed to do these types of things. So we're looking forward to doing it. We just have to make sure we get the right workflow that makes it easy for people. And then as I mentioned, we used to defer by job, which is why I put these X's, but now you defer by environment. And the reason for this is there are plenty of projects who have multiple jobs. We have one job, but there are plenty of projects that have multiple jobs. And I've heard it got hard for them to figure out which job to defer to. I have this job running and this job running, so do I defer to this one or do I defer to this one? So DBT was like, okay, you can just defer to your whole environment. You can have all these jobs running in production, and your production state's going to be the same at the end of the day, regardless of what job's running. But this actually caused an issue for us. So we use this macro called snapshot macro. So early DBT, I think 2019, if anyone knows, Claire Carroll came out with this macro snapshot that you basically override the ref and you put snapshot, with your Jinja of whatever your model is. And the reason for this is we wanted to be able to create snapshots in our dev environment and also in our production environment without running the risk of adjusting snapshots in our dev and breaking or changing the production version of it. We wanted to mitigate that risk. But this caused issues for us because when you defer to environment, that snapshot macro was not environment aware. So it was making it seem like every single snapshot macro or model was being modified every time. So every time our CI job run, even though we were trying to do some CI, every single snapshot was running every time. And so the way we got around this was all we had to do was take the config and move it to our DBT project YAML, the global YAML, because it is environment aware, and we got back down to that slim CI modified plus state that we were looking for. So that's just one thing I want to call out. So I want to now go into GitHub. So again, DBT doesn't have a concept of restart from failure. For us, this is part of Slim CI. We don't want, if we fail halfway through our job, we don't want to keep running the other half of those jobs because we got to that failure point. We want to restart from failure. So there's a DBTC package, which I think was a personnel of DBT who made it on their own. I think his name is Doug. Don't quote me, something like that. So we started leveraging that. So we built a GitHub action. Anytime our build would fail, it would restart that job from failure. But then the beauty of it is that it actually dynamically updates the build job that you have. So you have one job. It'll take it. It'll overwrite your run operation to say, instead of dbt build, give me dbt build -- model, all of the models that were downstream of the failure point. And it'll also take the consecutive run operations and throw them in there because it hadn't gotten to those steps yet. So it's really cool, and it's really useful for when you have things that are triggered and dependent on your DBT job, things like reverse ETL. There's no concept of logical operators of, let me have this job and let me have this job that's my restart state, right? Which is kind of where there's DBT retry coming out, but you still have to create another job, my understanding, that says DBT retry because there's no way to dynamically change that job. So now it's, okay, I have this build job that failed. I have this retry job that I need to trigger once the build fails and triggers it. But do you have a concept of logical? Trigger your reverse ETL when this job happens, and if it doesn't succeed, then trigger it when this happens. Or do you always have the retry job run regardless of if you have a failure or not, because the retry job is not really going to run anything. It'll take a couple seconds, but you'll get that success state to trigger your dependency. So I still don't know how this world looks. I'm definitely of the mindset that we want to dynamically change that one job so we can have all of our dependencies still trigger. The next thing that we ran into is for a good point in time before concurrent CI that I have here in blue, DBT did everything serially. And so this was part of where we were running into collision. So a good example is when we would submit a pull request, you would get a CI check against the pull request and every consecutive commit, right? So let's say I put a pull request. 1 minute later, I realized, oh, shit. We can curse, right? Whatever. I didn't add a comma or I didn't conform to the naming convention we wanted. Let me quickly put in a PR. But now you have 2 CI jobs running, which is very wasteful. So the way we mitigated this is very intelligent. You should all do it. We did draft PRs. We did a draft PR, and so whenever you do a draft PR, the CI job wouldn't run until we are ready to say, hey, this has been approved, convert it, and now let the CI check run. Because it didn't make sense for us to have syntactical changes, run models for something that has no bearing on the model itself. And what's cool about GitHub is we didn't have to teach our team members to always set it to draft PR. They had to do it one time. And GitHub will always remember what the prior state was, and it'll make your consecutive PRs draft. I think DBT now has a concept of like a checkbox where you can say like trigger CI checks from draft PRs. I think that's a thing. We haven't looked into that. But this also allowed us to manually gate how our checks were running. So like if I put a PR and someone else put a PR, to avoid those collisions, we were manually gating it by converting draft PRs. But again, that's because we shot ourselves in the foot. We had that shared beta environment. So it made us realize we needed to move to schema per PR. We were finally at the stage to do that. And then I have in blue here smart cancellation. So DBT did finally release that if I added a consecutive commit, it knew to cancel the prior invocation from the pull request and only run the most recent one instead of having all of them running simultaneously. So that got a little bit better and we didn't have to worry about it as much, which was nice. So the one thing I want to call out is when we finally moved to schema per PR, there's this very niche part of the documentation. I think it's on like custom schema name, the very bottom, you unfurl it. It wasn't working for us, and we didn't know why. And so we found this little, I don't think you can see it. We found this little part of the documentation where if you're overriding the generate schema name macro, it wasn't working. Like it wasn't creating the schemas, it wasn't dropping the schemas. You basically have to set a prefix that DBT has set, and it has to be that prefix in order for it to work. So luckily, once we found this piece of the documentation, we were able to rectify, and now we are getting schema per PR, which also has some other issues that we'll get into that we ran into. So a little bit of our DBT functionality is we moved all of our DBT utils checks into freshness, mostly because it gave us a nice little UI to look at it, and also it allowed us to do capabilities such as Fresher Plus. We haven't built it in, but that's another way to keep your pipeline super slim on the front end. What was cool too about freshness checks is I say it serves on quasi checks on ETL. We might not always be tied in with data engineering. So data platform, we attempt to be full pipeline, through and through, connected, dependent, and have observability. But sometimes things can fall flat. And so we could see like, hey, the Twitter source is stale. Did the ETL fail? And they'd be like, oh yeah, actually it did fail. So like you can use it as like a way to kind of check without having to check your alerting channels, like to quasi check that, hey, something is wrong in the pipeline. But we also use it to pass loaded at and last refresh at timestamps to all of our models and propagate that through BI. So stakeholders know if there was a failure in our pipeline or when the data was refreshed. If we were to have multiple runs, they know at what point. So we like to give that visibility so everybody knows the point of the data. So in freshness, if you're not familiar, there's two ways to configure it. So you can do it as a run operation within your job, or in DBT Cloud, there's a checkbox where you can say run freshness. The difference here, and I put the documentation there, the difference is when you do it as a run operation, if any of your sources are stale, your entire job fails. And we were like, hey, we don't really want to do that. So if you do it as the checkbox, even if some of your sources are stale, your build and your run, however you have it set up, will still succeed, and you can still trigger all your dependent downstream resources. We were okay with this. We're like, we know it's stale data, but we're okay to have it stale for the sanctity of the pipeline, let it keep running. And so that's part of the reason why we want to get into Fresher Plus too, is if it's stale data, don't run it because it's just wasting compute on rerunning data that's not refreshed. The one thing that I do want to call out is here at the bottom, eventually at some point DBT released filters. And so within the YAML, when you add this freshness check, I put a snippet there of how it looks, you can actually put a filter to limit the amount of data that you have. Because in cloud data warehouses, you always want to pre-filter data as much as possible, limit those table scans, it's more efficient. So before we added filters, our freshness checks also started to bottleneck. They started to get up to 8 to 10 minutes. But after we added those filters, you can see here, I added it to only look at data 2 days prior, because you have to determine the frequency of your source. So it might be dynamic based on source, and you can determine that frequency. For this example, I did 2 days. And we actually got that freshness check down to 1 minute. Again, this freshness is important, but when you're running this freshness check as part of your build, it also becomes a bottleneck because you're not getting to your build state, because you're still running these checks on your freshness. So that's just something to throw in there, just keeps everything super slim. So then we finally got to a point of complexity and scale where we had to do incrementals. And incrementals are very good for append-only data, for sure. But we also got to a point where we had very complex models, and we figured out ways to hack them to also give us what we needed, because we're starting to traverse into big data, and we weren't doing incrementals for the sake of incrementals. We're doing them strategically. And so I mentioned earlier that deferral is a little bit complicated. So what we did is we added a bypass macro similar to the snapshot macro. So we would actually take the ref, and we would replace it with bypass. And all bypass was doing under the hood was manually changing the schema and pointing it at production always, so you could imagine that's deferral. But nobody had to know that they needed to add the state flag or the deferral flag. It was kind of happening under the hood. And so there are two components to this. We added so basically any of our incremental models, because they're getting into the millions and billions of records, we put a config at the top to only build them in production. Don't build them in your development environment, and then only reference them against production. So even when I'm hitting, building a model in my local dev, it's always pointing to that production model because it's an incremental table. There are some caveats here. While it does make the workflow easier, it does give you a point of attack because somebody can unknowingly break that production model, right, without realizing it. So we did put some safeguards in there to do that, where in the YAML you could disable full refreshes, like you can do these things. So we put a couple of safeguards in there to mitigate that risk, but while making it easy for people to do local deferral development without having to do these like hard things and teach them to do these things. Another cool thing is that we could actually control F all of our refs and add bypass, and in development point to all of our production tables and test locally and build that new table in our dev while pointing to production models without having to clone them over or build completely in our development schema. So it's just a little bit of hacks. We do plan to build in incremental predicates. If you're not familiar, it's very similar to the filters of freshness. It's pre-filtering the data to make these things more efficient and reduce the runtime. One cool thing that we do is you can take an incremental table. Let's say you have your events table and you have late arriving events or something of the sort. You can do an incremental up until 7 days ago, and then you can recompute those 7 days or put it as a view that recomputes on the fly and union that together. And so let's say your events come in hourly and you only have one build in the morning. There's going to be a disconnect on that data. But when you do this, you can have that delta view on top to always have current state data. And the nice thing about what we were doing with bypasses on our tables, like event tables, is anytime that table was hit in development and beta, we were constantly refreshing that production table under the hood without having to have multiple runs per day. So it was a little bit of a hack to update tables without actually running DBT runs and DBT builds. Yeah, I think this is redundant on the schema per PR and how we want to eventually build in a command to clone things over, because when the PR gets the schema gets spun up, there's no incremental tables in there, right? Like as an example, and it wants to build them in there. We don't want that to happen. If there's an incremental table that takes 30 minutes to build, we don't want that to happen. We want to clone it over or figure out a way to defer it into production. And the way we would probably do that is I would build it in dev, and in Snowflake you can swap. I'd swap it to production, and I'd basically put a PR just for the SQL code, but not the actual running of the model. So you can start to get a little bit strategic about how you do these things. The last thing I want to cover, and I'll try to go quick, so I want to reserve some time for questions. We have about 8 more minutes. Is what we did with metadata. So we use Hex as a company, and we wanted to collect as much metadata as possible and put this into a Hex app that would serve as like our homegrown observability or like an admin panel for us. So we started using select.dev Snowflake monitoring and elementary data, which is open source observability. And prior to that, we were using DBT artifacts. So one of the founders of DBT artifacts is now on the select.dev team. So it's very similar. And we also took our Snowflake query history and we turned this into an incremental. The reason we did this is because I think there's a rolling, I think it's 365 days, which is a lot, but there's a rolling period where you lose historic query history. So we wanted to make sure we maintain query history of all time, so we could do a 2-year look back for whatever reason if we wanted to. I don't know why we would, but just in case. And so we would take the metadata from DBT, and this would allow, all of this metadata allowed us to join it back to queries inside of Snowflake, and we can now take Snowflake costs and attach it to DBT costs. We could do model and resource level costs, we could do job level costs. We wanted to be able to have observability across both the micro and macro level. So what we did in the Hex app, as I mentioned, we wanted resource level models. We wanted to know what models were unused, what models were long running. We wanted uptime monitoring, as you would go to like a down detector. So if our pipeline broke today and finance is like, why is it broken? We could be like, well, the last 3 months we've been green, we haven't been broken. Give us a little bit of slack. Things happen. Because as a data team, we all know most of the time it's not even our fault. It's somebody on RevOps who's did something wrong in Salesforce, or it's the engineers who's not thinking of the data team, and they changed the schema of a backend table, and we're at the mercy of these people. We love them though, but And so we also do model level steps, things like uptime, freshness, success and failure counts, all of these things. And eventually we want to build in like third-party API connectors as well, so we have an all-in-one place where we can see our full pipeline observability. So how that kind of looks is I took some screenshots of pieces of our Hex app. So this right here is job level monitoring. It looks very similar to the run history you would see in dbt. That's basically because it is. We just didn't want to have to log into dbt because we wanted to avoid clicking around to all these different tools. So we wanted to consolidate. So this is job level things that you would see in dbt. This is our uptime monitoring. This is some of the, over here to the right, we were taking dbt run builds across all of our dbt spend, across our Snowflake spend, because we wanted to account for local development too against dbt, all the things. We just wanted to get super granular. This is resource level metrics. We could take a distinct model. How many times has it run? How often is it failing? Is it a problem child? Can we go look at that? And you just start to do things like this. Has it increased in runtime 10% week over week? And just get that level of granularity. You could come into that distinct model, check its runtime against its cost. You could see it spiked on a certain day. You could go back in time. Was there a PR on this day? Was this PR related to this spike? Do we need a refactor? Just giving that level of visibility. And then here, what currently running queries are there? We have, here on the lower right, we have an abort button, so we could abort those queries. Again, all in one admin panel. Don't want to have to go to Snowflake and abort that query. We want to be able to do it all in one place. So basically, all of these strategies at the end of the day, when we first started running dbt, you see on the left that our costs were really high. And we're like, hey, let's get strategic. Let's start to implement some strategies like SlimCI and all these things and really cut our costs. And so all of the strategies that we've talked about, SlimCI, deferrals, freshness, and once we started implementing them, we actually cut our costs by 50%. And now that's kind of, there's some spikes here and there, but you can see this is kind of our steady state now. And this is all because we implemented these strategies. And now that dbt is releasing a lot of these natively in 1.6, it's going to make it that much easier for you to also implement these strategies. So I highly, these are marginal things you can do that as a collective have big wins. And so that's really what I wanted to pass along to all of you. And I think that is my talk, so we can reserve some time for questions. I'll go back to this one quickly because I think we all emulate. We thought we looked cool being David and Goliath, but really all we're doing is crying and not knowing what the hell we're doing every day of our life and hoping that it works. So I did add that one in there. You can connect with me on LinkedIn or any of the Slack communities that are out there in the data space. Cool. Now, QA. We have a couple minutes for questions if there are any. The bypass?
Yeah, for bypass. Do you have is there a place that we can see what that macro looked like? Or?
Not offhand, but really it was just pretty much replace the schema. It's like generate schema, just hard code in the production database. It wasn't anything crazy.
No, that makes sense.
Yeah.
Was any of your excess spend on Snowflake related to maybe a learning curve on Snowflake, multi-clusters and so forth? Was it mostly just already dialed in and you had to make it work in dbt better?
Yeah, generally that is. Luckily, we had a team that had knowledge of dbt and Snowflake already, so we kind of had that knowledge going in. But there is something there to be mindful of. At ClickUp, this is not something I mentioned, we employ a data warehouse first mentality always. And so every time a third-party vendor becomes data warehouse first, their tool itself might be pretty cheap. But there's all that Snowflake cost under the hood that you have to be mindful of, right? Because now when you take that Snowflake cost and you compare it to your contract cost, it might actually be more expensive than paying for the vendor that's managed and they run everything on their server. And so that's something you do have to start to be mindful of in this warehouse first world. Yeah.
Hey, nice presentation. We
Appreciate it.
Dev's Snowflake cost monitoring package for Snowflake metrics, but I'm curious about the dbt job cost. Is that a part of a package, or did you kind of wrote the code for it?
Yeah, so I believe there's two packages that they have, and one is one that basically takes the artifacts. So they do query comments, and they put the query comment in the invocation, like when dbt runs it, and then they parse the query comments later because you could pass the invocation ID of the dbt job and that model. Then you basically union those back to, or join them back together, and I think that's what they're doing under the hood. I haven't looked at it in a while. I would have to look at it again to remember, but it's basically something like that. Yeah, so I think there's a discourse that goes around where you do like if target equals dev, do like a limit in all of your models, right? I don't think we ever felt like we really needed to do that because in Snowflake you can just kind of clone it over. So what I would do, like let's say I had incremental and I wanted to add a column, I would just, and I don't have it in my dev, because when we start cloning, we actually exclude, I don't think I mentioned this, we exclude incrementals because we don't want to keep cloning this into multiple schemas, it's just wasteful. So we exclude those. So I want to build it in my dev, but I don't have it there. So I'll actually clone the production one down into my dev. I'll make the change when I feel comfortable with it. I'll actually run a swap and put it back to production. And so if for whatever reason that one wasn't good, I could also swap it back because it's the production version that was prior is in my dev. So it's almost like emulating blue-green in a way. Cool. If there's no more questions, I think we can call it there. Thank you, everyone.